Now, the example that talks about a trolling motor can push a boat at 1.1 miles per hour. Must have a dead battery. Okay, a trolling motor can push a boat at 1.1 miles per hour in still water, and the boater wants to get to point B across a river. All right, here's my boater, wants to get to point B straight across that river, okay? The problem is we have a current that's pushing, okay? And B is straight north. We got a current pushing that way. So what's going to happen if the boater points his boat, his or her boat, straight like that? If the current's pushing against it, it's going to kind of push his boater off, right? So if the boater wants to get exactly there, then they're going to have to angle at a direction like this, right? All right, if the current is 0.4 miles per hour due east, 0.4 miles per hour due east, 0.4 is pushing directly east. At what angle theta should the boat be navigated to reach point B? Round your answer to the nearest tenth of a degree. All right, so let me draw like either a compass or a coordinate plane here, okay? My boater wants to get to this point B right here, right? We said that this boater is going to need to steer what? Like that, right? Okay, the boater's going to need to steer like that. Now, what is the magnitude of this vector right here? This vector has a magnitude of 1.1, right? And we need to call that vector something. Let me see, just to stay standard with my notes. You can call it whatever you want, but I'm going to call that vector V, okay? And what's happening is current's pushing against it directly east, right? So your current vector looks like that right there, we could say, basically, okay? So it's going in that direction. But if I put it right here, if I put the tail of that vector at the tip of this vector, then I can look at vector addition, okay? And let's call this the current vector, like that, okay? So in other words, vector V plus vector C will get you to point B, right? Okay? And I went ahead for some reason and called this vector R in my notes right here, from here to point B, okay? So in other words, if I add up V and C, I will get vector R, okay? All right, so what does it say? If the current is 0.4 miles per hour due east, at what angle theta should the boat be navigated to reach point B? So they want to know what angle right here, theta. All right, so what did we talk about? We said vector V plus vector C will get us there, right? Vector V, let me actually make some more room here. Vector vector V plus vector C will give us vector R with vector addition. Okay? Let's look at vector V. Let's break it down into a vector written with the vectors I and J, okay? So how do I write vector V in terms of I and J? Vector V will be some AI plus BJ, right? But how do I write that? I write that as the what? Magnitude of vector V times the cosine of theta times vector I plus the magnitude of vector V times the sine of theta times vector J. That's vector V, right? Plus vector C, but what does vector C look like if I put it in terms of I and J? Basically the same way, right? The magnitude of vector C times the cosine of theta I plus the magnitude of vector C times the sine of theta I is equal to vector R. What does vector R look like in terms of I and J vectors? It looks like the magnitude of vector R times the cosine of theta I plus the magnitude of vector R times the sine of theta I. So let's see. What was the magnitude of vector V? What was vector V now in a picture that I erased? Magnitude of vector V. What I have? I had something that looked like what? basically look like this. Okay, we said that was what? Vector C for current. We said that this was vector V here. And what do we call this other vector? Vector R, right? So what was the magnitude of vector V? How fast is my boat going? 1.1, right? Times the cosine of theta. Now, what is this value right here? Theta. I do not know what that is, right? So theta stays theta times vector I plus the magnitude of U is 1.1 again times the sine of theta, I don't know again, times vector J plus the magnitude of vector C. What is my current? What is the speed of my current? 0.4 times the cosine of theta. What is the angle of my current right here? If we think about the current vector being here, what would the angle be? 0 degrees times I plus the magnitude of C again, which we said was 0.4 times the sine of 0 degrees times vector J is equal to the magnitude of vector R. I don't know what that is, so that stays the magnitude of vector R times the cosine of theta. How about vector R? What is my theta value of R if I rotate from here to here? 90 degrees times vector I plus the magnitude of vector R, which is still unknown, times the sine of 90 degrees times vector J. All right, so let's see what we got. We still got 1.1 cosine of theta times I plus 1.1 sine of theta times J, right? Plus, how about this part? At 0.4, what's the cosine of 0? Cosine of 0 is 1. So times 1 times vector I plus 0.4 times the sine of 0 degrees. What's your sine of 0 degrees? 0 times vector J is equal to the magnitude of vector R. Do not know the magnitude of vector R, so I'll keep it as the magnitude of vector R times the cosine of 90 degrees. But what is the cosine of 90 degrees? At 90 degrees, my cosine is 0, right? Times vector I plus the magnitude of vector R times the sine of 90 degrees. What's my sine of 90 degrees? 1 times vector J. All right, I'm going to have to erase this picture here. I can redraw it later. So we get 1.1 cosine of theta times I plus 1.1 sine of theta times vector J plus 0.4 I here. What happens with this stuff? That stuff just zeroes out right here, right? So plus 0 is equal to, what happens to this stuff? It just zeroes out as well. Plus the magnitude of R times what? Vector J over there I have. All right, now let me put my parts of my I vector together here. So I'm going to have 1.1 cosine of theta times vector I plus 0.4 times vector I plus 1.1 sine of theta times vector J is equal to the magnitude of vector R times vector J, right? Now right here, I can factor a vector I out of this, and I could say this is 1.1 cosine of theta plus 0.4 times vector I plus 1.1 sine of theta times vector J is equal to, now what I'm going to do right here is I'm going to put in 0 times vector I plus the magnitude of R times vector J. So I just inserted right here 0 times I. Now why did I do that? Because what I could do is, if this stuff is equal, I could say the stuff multiplied by the I vector is equal to the stuff multiplied by the I vector. And the stuff that's multiplied by the j vector is equal to the stuff that's multiplied by the j vector. So I'm going to take the stuff that's multiplied by the I vector, 1.1 cosine of theta plus 0.4, and I'm going to set that equal to what's multiplied by the I vector here, 0. Okay? Now, why could I do this? What if you had AI plus BJ is equal to 3I plus 4j? What would you conclude in that? You would conclude that A is equal to 3 and B was equal to what? 4. Because these vectors are equal if their components are equal. So that's exactly the same thing I did here. This was my AI and this was like my 3 over there, okay? So A is equal to A is what I basically said. Now let's solve this, okay? Cosine of theta is equal to negative 0.4 over 1.1. And then if I take the inverse cosine, what am I going to get here? I'm going to get approximately, oh, I did that somewhere. Approximately 111.3237 degrees, okay? All right, so in the picture that I had earlier, I was looking for this angle right here, theta, okay? Didn't I just come up with that angle theta? And they tell me to round to the nearest tenth. So I would say 111.3 degrees. For some reason they want that here in Alex. I would have thought that they wanted north, so many degrees west. But they actually want this number. Good luck.